Hi everyone. So now we are going to discuss inventory management. So let me keep it very crisp and short. So first and foremost point is like what is inventory? So what are all the different categories of inventory that we consider? It can be raw materials, it can be work in progress materials, finished goods but still lying down in the warehouse, and any tools and supplies that are needed or any maintenance related objects that we do have and goods in transit which are accountable to us. So usually companies do follow two different methods, push and pull strategy. One is like uh, the supplier once send the goods would become the responsibility of the supplier until it reaches the vendor or the company. So that is one way of calculating what comes under the scope of goods in transit. And second thing is like once the supplier ships the products, it becomes the complete responsibility of the company to consider whether that is reached or not and the invoice is taken care or not. So that is like another strategy. So based on this, whether it needs to be included in the inventory or not will be calculated. And inventory, of course, is very important to streamline the production and to not to get into any troubles in between because of shortage of materials and because of it can be multiple inherent costs associated with shortage of stock. It can be loss of business, it can be loss of reputation. So all those things will be considered as well. So it is very crucial to forecast the need that is forecast the inventory that is needed, plus how to manage that inventory. And there are two concepts that are, 2 points that are important for inventory. One is when to order and how much to order. So how much to order is nothing but the quantity. How much can we order, that optimal quantity, which will give the best suited, we will not miss our business, and at the same time we need not hold it for a longer duration or uh, you know uh, the problems of holding too much of inventory will not be coming into picture, like the product being deteriorated or the holding costs are too high, so such problems will not occur. So that is the optimal quantity that we are going to discuss over here. And next one is when to order. Once we place the order, for it to come back and reach us, it takes certain time. So by that time, we should not run out of inventory again. So what is that optimal point when we order, so that by that time it reaches us, we are sufficient enough with we can survive with the existing inventory itself. So these two becomes the crucial points of inventory management. And even before to get into how to order and when to order, how much to order, we should know what is our existing inventory also. So we should be efficient enough to count the existing inventory and to come up with uh, what is existing and how much are we consuming also. So one way of counting that is perpetual method, which is like continuously we are counting our existing inventory to understand how much is remaining, and like periodically we keep on counting it. That is the perpetual method of counting the inventory. Second one is two bin method, where we keep two separate areas for the inventory. So once the first bin is over, that gives an indication, okay, now we are moving to the usage of second bin. Now is the time to reorder. That is the two bin method. And UPC is our barcode system, and using the barcode system itself, we will or a QR code related systems, where by looking at by scanning the QR codes, we will be able to tell how much of inventory of that particular product existing remaining in the warehouse. So this is another way of counting perpetual, but we need not specifically count it. Using this technology itself, we will be able to tell how much of the inventory is remaining. So these are various methods, and there might be many more also. So once we count what is the inventory available, based on that, we are going to consider when would I be needed to reorder and how much quantity do I need to reorder. So this is what this entire chapter is majorly focusing on. And coming to the inventory cost. So there are like there are multiple costs associated with it. One is the purchase cost. Purchase cost is nothing but what is the quantity we are ordering multiplied by the cost of that particular good. So this one we identify it as Q into C. We give it as Q multiplied by C. C is the unit cost and Q is the quantity that we need. And this is inevitable. Like the moment we order, we are planning to purchase something, unit cost is inevitable, and the quantity is that much of quantity we anyway need it. So this purchase cost is something that we cannot avoid, we cannot optimize much, we cannot, so this is not of much concern for us because we are prepared for it. And second thing comes into picture is like holding cost. So this holding cost is like how much are we holding, okay, and the cost associated with it. So if we hold it for a longer duration, there would be many costs that comes into picture, and it can be represented in two ways. One is percentage of unit price and dollar amount per unit. So let us say a product is costing us $100 or ₹100. So the holding cost is like some 5% of it. So that means $5 is annual. Let's say this is annual. So our annual holding cost is $5. This is one way of representing it. Or second thing is straight away giving, okay, for that particular order, this is the holding cost. Holding cost per unit is going to be $5 straight away. It can be given in both the ways in the problem, and even in industry standard also it can be represented in both the ways. So the holding cost includes like our warehouse costs and the electricity, all those things. What is the cost that is associated to hold this much of inventory in our warehouse? Second thing is ordering cost. Ordering cost primarily depends upon two things, that is number of orders and order quantity. So if the order quantity is more, then the number of orders are going to be lesser. Both are inversely proportional. So if our quantity is more, I'm writing here, quantity is more, number of orders would be less. If the quantity is less, we need to frequently reorder, so the number of orders are going to be more. And the costs associated with it are called ordering cost. So usually this is given in dollars or rupees directly per order. Per order, this is the ordering cost associated with it. And usually the sorting, once the material is shipped to us, like what is the sorting cost and rearranging them and placing the order, like invoicing, those costs are calculated or considered under ordering cost. Another one is shortage cost. This is nothing but once we lack, move out of inventory, once we ran out of inventory, what is the risk associated with it and corresponding cost? Like, as I said, loss of business or loss of trust, uh, reduction in brand value, all those things come under this shortage cost. Or maybe the machinery itself is getting damaged because it is not being operational. So very rare though, but yeah, these costs would be considered under shortage cost. Now, when we dig deeper into this one, how much to order? So we are now looking at into these two elements, how much to order. So the quantity to be ordered can be determined by three different ways: basic economic order quantity model, economic production quantity model, and quantity discount model. But for us, only this is in scope, and this is the easiest way of calculating it in practical scenarios also. So the whole meaning of this one is like economic order quantity. What is the quantity to be ordered to keep the prices at the lowest possible value? That is economic order quantity. So as I said, we will be talking about carrying cost or the holding cost and ordering cost. So what is the quantity at which the holding cost and ordering cost are kept minimum? Now, let me just write it down. Total cost equal to our purchase cost plus ordering cost plus holding cost. As I said, this purchase cost is inevitable, so we are not giving much importance to this one. It is simple calculation of Q into C. Now, our primary focus would be like optimizing this one, ordering cost and holding cost. So, coming to the carrying cost or the holding cost, let us discuss this first. So, this is how the inventory consumption looks like. So, this is like quantity and this is the time. So over here, what we are saying is like this is the quantity that we need, and as the time progresses, we would be consuming this. We would be consuming this much of quantity, and then ultimately it becomes zero. Actually, it reaches zero. Sorry. So from quantity, a certain quantity, with as time progresses, we would be reaching zero, and then again we reorder, and then we reorder this particular quantity. As time progresses, we would be consuming this and then it will become zero. So this would be the cycle. So the holding cost would be like, okay, from it starts with Q and ends with 0 divided by 2. So this is nothing but the average quantity multiplied by H. H is nothing but our holding cost. So that is how this formula is derived, Q by 2 multiplied by H. And next, here one more concept that we wanted to tell is nothing but lead time. So another concept that we are going to talk about here is the lead time. So when in practical scenarios, once the quantity reaches to certain level, we have to reorder. So the point at which that we have to reorder will be determined by, maybe this line. So I would say that reorder point line, and the moment we reorder versus, to the moment when we actually receive the order. This time period is called lead time. The time when we reorder to the time when we actually receive the order is called lead time. It is given in the book as well as simple example that we wanted to highlight over here to understand what is lead time. That let us say we are consuming 7 medicines per day, and once we reorder, it takes 2 days to receive the order. So we should be ordering when our quantity, the remaining quantity equal to 14 medicines. That is 7 into 2. So by the time we completely become zero, our new order would be received. So when we are left with 14 medicines, we have to reorder. That is lead time. We would discuss more on that one later, but Here one point is annual carrying cost and another one is ordering cost. So this ordering cost is nothing but we are in need of some D quantity. Let me not say it as quantity, let me say it as demand. So D is the demand and Q is the quantity per order. So D by Q will give how many times are we ordering. Let us say I am in need of 1000 quantity, and for each order I am ordering only 100 quantity. That means 1000 divided by 10. So I would be ordering 10 times. So that D by Q gives the number of orders. And for each order, there is a cost associated, which is S. So number of orders multiplied by the cost of each order gives you the ordering cost. So that is the funda of D by Q into S. Now, using mathematics and using our understanding calculus and all those things also, we can say that the total cost would be minimum when annual cost equal to ordering cost. Annual carrying cost, holding cost equal to ordering cost. So at this level, it is believed that the quantity is more economical, or let us call it as EOQ. Economic order quantity would be that quantity at which holding cost equal to ordering cost. So when we equate both of these values, what we would be getting EOQ equal to 2ds by h square root of. That is how this EOQ is calculated. And there are multiple assumptions associated with this economic order quantity. And the first one is like only one product is involved. So let us say there are multiple products. The similar exercise is repeated multiple times, one for each product. And annual demand values are known. So we know our demand values, we know our lead time, and they are spread across very evenly. That means this cycle is repeating again and again without any problem. And one order equal to one delivery. That means if we order some 1000 quantity, all 1000 quantity will be delivered as part of one order only. It would not be like 100 quantity in one order and 100 quantity in another order like that. It will not be distributed like that. And there are no quantity discounts. So these are basic assumptions with which we are involved. When we say there is no quantity discounts, what it means is like, let's say we are ordering 100 quantity, there is one price associated with it. But when we are ordering 1000 quantity, there will be a different pricing system that the supplier offers. So that is not applicable. Irrespective of the quantity, it is the same pricing. Practically, these may not be viable, but yeah, these are the assumptions with which this entire theory is derived. Now, as I mentioned, lead time. Lead time is nothing but the time between when we order to when we receive the order. So that is lead time. So that lead time multiplied by D. So D is nothing but the annual demand or whatever is the period. Okay, demand in that particular period. So reorder point is nothing but the lead time multiplied by D. So it is a similar explanation that I gave in the example above, that if we have 7 medicines consumption per day and it takes 2 days to come, so this is our D and this is our lead time. D into LT, that gives us the reorder point. Okay, we need to reorder it when we are left with 14 medicines. That is our reorder point. But it is, in ideal world, this should work. But there are, considering the practical difficulties, we do have various other deviations. And the first and foremost thing is stock out, safety stock that we need to mention, that we need to hold. So what we are doing here is, this is the safety stock that I wanted to keep at any point of time, this much of quantity. So always this is quantity and this is time. So this much of stock that I want to keep it as my safety stock to address if there are any deviations in the demand or any issues with the existing inventory or something like that. So I would not like to consume this much of quantity unless otherwise it is really needed. And our order would be like this. Sorry, it has to be a straight line. So this quantity is called safety stock. And that safety stock is what we are actually uh, calculating. And what we are saying is it is not just the expected demand, but we also need to consider the safety stock for the reorder point. And this safety stock is determined using the stock out risk or the service level. So here the QT concepts come into picture of the Z score and the standard deviation and all those things. So let us say there is a service level of 90% that is expected. Okay, that means I am okay to have a stock out risk of 10%, but I want to provide the service level of 90%. 100 minus this stock out risk 10% is called service level. So for this 90%, I would be calculating what is the Z score, and that one multiplied by the sigma, the standard deviation, will give us the safety stock. So in the simple example, your expected during lead time, this is nothing but D into LT plus Z into sigma DLT. So please observe, it is like a standard deviation of demand and lead time together. Now there are few other variations to this one, that even the demand can be uncertain. Here we are saying demand and lead time both are certain. We know it. And if demand is uncertain, we would be deriving derivations of this particular formula, and we will end up having this formula using calculus, that if demand is uncertain, D is, okay, this bar over here indicates the average demand. So average of that particular value. So here it is average of demand multiplied by lead time plus Z score of sigma D. Sigma D is nothing but the standard deviation of demand and square root of LT. So basically what we are saying over here is this component is equivalent to sigma DLT. And that's what it is mentioned over here also. When demand is uncertain, sigma D square root of LT is as equivalent as sigma DLT when there is demand certain. And another formula over here is when lead time is uncertain. So sigma LT is the lead time uncertainty. So D multiplied by LT plus Z into D sigma LT. So over here we can just remember the formula and then we can substitute those values, because these are all like pure mathematics with which they are derived. So there is no need to remember, or there is no need to derive these formulae. And another point is both demand and lead time are uncertain. So here we are considering average of demand and average of lead time plus Z score of these. Okay, so average lead time and average demand. So few pointers that I would like to mention over here. One is whatever is uncertain. If demand is uncertain, okay, they would be mentioning average demand. The terminology of the questions would be like, if demand is uncertain, only then we will talk about average demand and standard deviation of demand. If lead time is uncertain, then they would be talking about lead time average and standard deviation of lead time. So uh, in the question, we can go through what is the average concept that they are talking about. Are they talking only about average of demand or average of lead time or both average of lead time and average of demand? So based on that, we can use the formula, and always the Z score, the standard deviation would be related to that element only. If demand is uncertain, then it is sigma D that we are talking about. If the lead time is uncertain, sigma LT is what we are talking about. So that's all. In here, it is a few pointers that I would like to mention related to the problems. One is the demand, quantity, holding cost, ordering cost. Okay, holding cost, ordering cost, all have to be mentioned in the same units. Like, are we talking about per week or per year or per month? So whatever is the consumption and the cost associated, everything has to be brought to one single unit and then substitute the values. If it is per month holding cost, then even the quantity that we are talking about has to be in per month, and demand also. This is one tricky part of the problems. And another one is about even the lead time. Lead time also should be according to that only. So everything has to be represented one particular time period only. And rest of the things are pure substitution of the mathematics into the formula and then getting the values. Thank you.